This is video 21. In this video, we present a result which will be used in the following video. Consider a simple B-infinite window W which is not a cycle. This window is in gray. The graphs G1 and G2 are the cut of the grid associated to this window. Consider the following hatched path P which satisfies several hypotheses. This path is basic, negative. Its last edge belongs to G1 and it starts at the position of this last tile. Here the path P is in white. We aim to find the following hatched path A. This path is a basic arc of G1. Its first position is the first position of P. Its last position is the last position of P. It belongs to the interior of path P. Finally, it is not elementary. Consider the interior of path P. Its window is in gray, its interior is hatched, the window W is in white. This graph is neither a subgraph of G1 or of G2. Now consider the interior of the arc A. This interior is a subgraph of the interior of path P, but it is also a subgraph of G1. Our aim is to shrink the interior of the path P such that it fits inside the graph G1. But at the same time, we do not want to shrink the path P too much. The arc A should intersect with the window. Here the position A33 is also the position W23 and thus the arc A is not elementary. Consider the path P. We now explain how to find the arc A. Consider the largest index J1 such that Pj1 is in the window W and J1 is not the last position of P. If J1 is equal to 1 then P is an elementary arc of G1. We suppose that this is not the case. By hypothesis the last edge of P is in G1. Then the segment of P from J1 to its last position is an elementary arc of P. Now, we focus on the segment of P from 1 to J1. This segment is hatched. Consider the decomposition of this segment of P in extremum arcs in G1. In this example, this decomposition is made of 4 arcs. Since the path P is basic and since the last position P is where P starts in W, then the position P1 is the first position of the arc A1. Then the arc A1 is positive. This arc is drawn in red. By definition of J1, the position Pj1 is a position of the window. If there exists no arc of the decomposition such that the position Pj1 is last position of this arc, then P is not simple, which is a contradiction. Then Pj1 is the last position of an arc of the decomposition. In our example, this arc is A3. Moreover, this arc is negative. We draw it in blue. The case where this arc is positive is studied in the article available online. Consider the dual decomposition of the window W. The last position of the dual segment D2 is the last position of A3, that is to say Pj1. Then the dual segment D2 is positive. This dual segment is in red. From the main result of the toolbox, the arcs A1 and A2 in the dual segments D1 and D2 are positive. We can define the arc A as the concatenation of the positive arcs, the positive dual segments and the segment of P from J1 to its last position. This arc A is basic. Its first position is the first position of P. Its last position is the last position of P and it contains the position Pj1. Thus it is not elementary. We now have to prove that this arc is a subgraph of the interior of P. Then consider the interior of the path P. The window of this interior is in gray. The interior is the left side of this window. The window W is in white. Remark that the arcs of the decomposition and the segment of P from J1 to its last position are also segments of the window of the interior of P. Remark that the dual segments are elementary arc of this window. Moreover, by the remark done in video 19, they belong to the left side of this window. In other words, they belong to the interior of P. Then the arc A is a subgraph of the interior of the path P.